Okay, so this should be the final video on this little excursion on derivatives and their use in economics. And I'll have here again Excel open, and you can see where we left off in the previous video. So what we try to do is first we try to find where is the optimum solution if your utility function is u equals 16 times the square root of x and your total cost function is whatever you see here. So we already derived the marginal utility and the marginal cost. And if we replicate that in Excel, we should get a graph similar to the one that you see here on the bottom. So let's do that first. So let's first create the x-axis. And let's create a column that goes again from 0 to 10. And we hope that in this domain there will be the solution. So we go again home, and there's something called fill, series. Let's do again a step value of 0.1. And let's stop at 10. Okay. So next we look at the marginal utility function, and we set the marginal utility is equal to 8 divided by the square root of x. And again, the square root of 0 is 0, and we cannot divide by 0, so we'll get an error message, but that doesn't keep us from copying down that formula. And then I'll just blank it out, or I'll just say this is a number which is not available, and then Excel will ignore it. Okay, we also need the marginal cost, and the marginal cost is equal to 0.15 x squared. So 0.15 times x squared, then minus 1.5x plus 4 minus 1.5 times x. Yeah, you couldn't do that. That Excel will obviously not understand that. So I have to click here, plus 4. Okay. So now let's see what those two graphs look like. I highlight now all columns, and then I go to insert recommended charts, and Excel will know that the first column will be the x-axis, and you can see here's a graph. It looks very similar to what we had here. Let's make it a little bit smaller, and maybe let's pull it up. Okay. So now let's nicify this graph again a little bit. Format axis on tick marks. Let's have tick marks 10. And the labels are also 10 units apart. Okay. And now we don't really need a header. We know it's marginal utility and marginal cost. We still can add the vertical grid lines if we want to, and maybe axis title, primary, vertical. Okay, so here we have both marginal utility, which is blue, and marginal cost. Okay, let's make it a little bit smaller. And now we see that the optimum solution is somewhere here, maybe at 9 or close to 9. And so we can determine it graphically, but we also know that we can solve this equation here. And solving this equation by hand, that would be really complicated, but it is a piece of cake for Excel. And let me quickly show you what we will do. So what we do is, we know that this condition needs to be met. So what we do is, we just can rewrite. We subtract on both sides 8 over the square root of x, and we just rearrange terms. So rearrange. Okay, so then we get 0.15 x squared minus 1.5 x plus 4 minus 8 over the square root of x. That has to be equal to 0. So we just rearrange what we needed to solve here. Okay, so now there is something in Excel which is called goal-seek, and what we need to do is, we have to create, anywhere in the Excel sheet, we create something that we call x. And so now let's say we plug in a value, for example 0. Well, if x is equal to 0, what is then the value of this equation here? So I just write here, the value of the equation is equal to 0.15 times, and now this x squared minus 1.5 times this x plus 4 minus 8 over the square root of x. So we get an error message. Maybe 0 wouldn't have been the best. So let's plug in 1. So now you see, if I plug in into this value 1, I get a value of negative 5.35. From looking at the graph, I can tell that the optimum solution should be around 9. So now I just can play around with other values, and I should see, as I approach 9, I get closer to the value of 0, which would be 9. And you see this is pretty close to 9. It's not exactly 9, but pretty close to 9. Okay, but anyhow, Excel has the power now to determine exactly what the optimum value is. We know it's around 9, and 9 is definitely good for our purposes, but I just want to show you quickly how to use Excel to solve for an equation like this one. So I think it is under data. There is something called what if analysis, and then you go to goal-seek, and then it becomes pretty straightforward. It says set the cell F15, okay, so this is the cell, this is correct, to the value of 0 by changing that cell. Okay, so let's see what we get. So now the optimum solution is actually 9.01. And what Excel did is it just used its computational power to play around with different values like 1, 2, 3, 4, but also 4.1, 4.01, and all those values until it finds the optimum solution. So this is a pretty powerful tool. So let's say if I have here 15, it doesn't matter with what I start. I just go to data, what if analysis, goal-seek, and you want to set the cell, this one, to a value of 0 by changing that cell. Okay, and then you just tell Excel, give me the answer. And we get again 9.01. Okay, so now this is the optimum, and it is an optimum because at the value of 9 we essentially maximize our total surplus from consumption, the extra utility over the extra cost, by looking at this area here. So this is our net utility. And of course that could be also calculated by looking now at the total cost. If we plug in a value of 9.01, let's just say it's 9, then we can look at the total cost, and we could look at the total utility, and then the difference between total cost, the difference between the total utility and the total cost would actually be this area. I still can't do it quickly, I'll just write it down. So I just say total cost. Total cost was equal to 0.05 times the optimum value cubed minus 0.75 times the optimum value squared plus 4 times x plus 5. So that is the total cost if we want to produce the optimum number of x. So we have cost of 16.7. Then the total utility is equal to 16 times the square root of the optimum. Okay, and then if we calculate the net utility, which is total utility minus total cost, that is now simply the 48 something minus the 16 point something, and we get 31. So this 31 is the area between those two curves. But anyhow, so the focus of this was on derivatives and their use in economics, and I hope that this has helped a little bit. So let's just stop here.